Here we are. Time to do some upgrades. Here's what we got today. KBD bushings for the head. All right, tools you're gonna need if you have them would be 5.5 socket head, or millimeter, that is 5.5 millimeter, and a 2 millimeter Allen head, hex head. Alright, now for the fun part. Now we get to take the head apart. Now that we have all the space to work with, you're going to take two 1.5 millimeter hex heads. Unless you know how to do something that I don't. Watch it. You do have like a little brass washer on there. Don't want to lose that. And pop the link. I'll do the same thing on this side. Set the tools aside. And back together. Next thing you want to do is take a look at how shredded these bushings are. Alright. Just not good. Not good. This side, it's not too bad. And then this other side is just straight up nasty. Now mind you, these are the bushings that come with the EXI's head. These are the stock bushings. Alright. It just made a mess all up in here. Just all shredded. Well, hopefully we're putting an end to that today. I try to put everything away, or back together again, cleaned, and recoated with oil and grease. Now with your thrust bearings, you're going to want to try and get some white lithium grease up inside those. That's preferred, or that's what I prefer anyways. Alright. Now something else you're going to have to do is you're going to have to grease up the feathering shaft a little bit so that these grommets will fit correctly, or the dampeners will fit correctly. With these ones being as stiff as they are, we're going to need some grease to get them on the feathering shaft. So just take a little bit. Alright. So what we're going to do, attempt to drop it back in. There you go. Now you got this little collar. I'm going to put that on next. And then bushing, or the, actually not the bushing, it's the dampener. All right, and that's first side. Again, the old one, all tore up. I don't know if this thing's going to focus on it. Doesn't want to, but take my word for it, it's chewed up. Damn. Pretty easy. There we go. Of course, once all this is back together, I won't be able to spin these like this because there'll be stuff in the way. But considering the quality of this particular helicopter, that's pretty impressive to see that kind of freeness in the bearings. And again, we're going to put that collar back on. And the dampener. Slide this back together and together. Now here we go for the second half of what's gonna hopefully prevail in a better flying helicopter. Just to see where I'm at. I had to take the servos out, got the motor out. Servos are just hanging there. If you've worked with this style, with the Align style Pro helicopter, you know that getting down into the motor be a tad bit of a pain, just because you got to remove the servos. But anyhow, on for the fun part. All right. Here's the motor that I had originally put in there. Just until I lost part of the label from the heat and everything. The label peeled, and while it was in flight, it just finished dripping off. Got really lucky that it didn't really interfere with too much of anything. But this is just a 3000 kV Exceed Helium series motor. Not a whole lot I can say about it. It's an inexpensive motor. It'll do the trick if you're looking to get something that's somewhat decent but low in cost. But to show you what I'm going to be upgrading to is this guy right here. The Scorpion 2221-8. This is a 3,595 kV motor. It runs at about 475 volts, I believe, approximately 42 amps on an 11.1 volt battery, which is a 3-cell light poly battery. I've already got the pinion placed. I went ahead and did that earlier just to save you the grief of showing you how to line it all up, because if you watch the videos that they have online, you'll know how to do all that. As you can tell, one is definitely bigger than the other. Alright, the Scorpion motor is a competition style motor. It's a lot more higher quality, so I'm hoping to improve flight efficiency. With my current electronic setup, I am gaining some flight time. I haven't actually gone through to see exactly what the flight time is going to be, but adding this newer motor to it, I may be going back down to my normal flight times, so we'll see what happens. Some other things that I did off camera was I had to figure out the wire setup, which wires had to hook up to what, so I got the proper rotation, because once this goes back together I will not be able to flip the cables around to test all of that. With the Scorpion ESC that I am using, as you can see right there, what I ended up having to do was I ended up having to match this yellow wire right here to the red wire on the ESC, and the red wire on the motor is going to the yellow wire on the ESC, and that will give me the counterclockwise rotation of the motor, which produces the clockwise rotation of the rotor head. So I went ahead and did that earlier. If you notice on the head of the motor, there's some scuff marks and everything from when I tried to get it set up inside the helicopter so I can get the proper spin rotation on it. And let me tell you, this thing was a pain in the backside to get put in. The original mounting screws for my Exceed motor are these 2mm button head style or cap style screws. And going to the Scorpion, they give you a 2.5mm size Allen bolt. It's definitely a much thicker bolt. So trying to get it through the motor mount down inside was a small challenge, but it did go in. Now to go ahead and finish getting this thing set up or installed so that we can get this thing fired up. The easiest way to do this is you really can't see it, but you're going to feed the motor up through the bottom of the airframe, and you're just going to guide the wires up through the top. And I'm guiding the wires in the motor towards the front of the airframe. So that's where all my hookups are going to be at. And basically it's going to go in just like that for right now. Now there really is no easy way to do this. The easiest of the ways that I found for this particular setup is to get one of the screws started, or just raise it up to the screw and then get it started the best you can. So that it just barely hangs in there. And then for the second one, you're going to have to use the cables on the motor and your Allen driver or your hex key, whichever you're going to be using, all at the same time to get this thing to line up. Now if you notice, I haven't even done the thread lock portion yet. From trying to get this thing in here earlier, I decided that would be best to get done once you get the motor fully mounted, so that you know that your holes are going to line up correctly. And there you go. Right now it's just in there. I haven't really. Next we have to go in and set the pinion mesh. Again, there's plenty of videos out on the web that'll show you how to do this. For brevity's sake, I'm going to not show you that part. But that's basically how you're going to install this, and then go through and you hook up your cables and you have to reassemble the rest of the helicopter. Just to show you, I'm going to go ahead and flip on my transmitter. Alright, I'm going to switch air this time, which is good. Now I'm going to go ahead and plug it in, and that tells you that the motor is activated on this particular ESC. Now I'm just going to give this real light throttle. Alright, and it looks like we have our clockwise direction. Go ahead and unplug. Turn off your transmitter. Now, just to give you a quick idea of how to set this thing up, the ESC, because I haven't done that yet, it's real simple. Let me grab the program card. The program card, set it down back here. Alright, when you first get the ESC, the first thing that you're going to want to do is, before you even plug it in, alright, you want to make sure you have everything hooked up. In the back, I have permanently mounted the infrared controller. I may not be leaving that in the whole time, but for right now I'm just going to leave it on there until I'm satisfied with the settings that I do have. And the way you hook that up is you take the receiver cable that goes from the ESC and you plug it in the bottom of the infrared card. The cable that comes off the top goes into your receiver. Alright? For normal operation, with it in this orientation, you want the switch in the up position. Alright? Which is the PPM position. Alright? And then when I plug in the helicopter with the transmitter on, you get that sound. Now, as soon as you switch the switch to the down position, you get the 3 tones. Alright? But for this first step, you want it in the up position, or PPM. And that just tells you that the motor is now engaged. Alright? Now, for the first step, first thing you want to do on your transmitter, you want to take your throttle stick and move it to the up position. Alright? You want to plug in the ESC. Get 2 beeps, move the stick down, and now it should be engaged. And that's how you set the throttle limits on this ESC. It's really simple, as you can tell. Now, one thing that you're going to have to pay attention to is I had to reverse my throttle on my transmitter in order for this to work. If it doesn't work right away, I would try to reverse your throttle and see if that's what the issue is, and everything should be good to go at that point. Now, we want to go into programming the ESC. You want to take your slider switch back here. You want to put it in the down position and wait for the tones. Alright, now we can program this thing. LVC 115, enter. And you get the confirmation saying that it's been set. The directions say that you can do this in 0.2 increments. Just to show you, I'm going to go LVC 113, enter. There's no confirmation. So you go LVC 110, enter. It takes it. LVC 115, enter. It takes it. LVC 117, hit it. It doesn't go. So you definitely want this in 0.5 increments. So the closest that I can get to the 11.1 volts is 11.5. That'll keep me on the high side. I could go to 11.0, but I'm not going to do that. I'm just going to leave it set the way it is. Alright. your motor acceleration timing delay, which is MAT. This is going to tell the ESC how quickly to spool up the helicopter once it's initially, once you initially slide the throttle to the up position. I just flipped my throttle hold switch on. Right now, I have a spool up set at 0.07, but just to make sure, I'll show you how to do it. You hit the MAT button, and then you have 5 options: 1, 2, 3, 4, and 5. All right, I'm going to set it for option 4, which is 0.7 seconds. So I hit MAT 4 and enter. Get the confirmation. It's good to go. Let me do it again without me talking. And there you go. It's set. And SS, which is your soft start. There's 2 modes. You have a heli mode with soft start, variable throttle adjustment, soft start. Then you have option 2, which is heli mode with soft start and governor. I'm not going to be setting up the governor. Your motor rotation, which is your RO button, is not available on this model. Timing, I have it set to auto timing, which is option 1. And again, if you wanted to change it, you just hit TIM, the 1 through 6, and then enter. And then that'll set it. My P gain is set at 5, and my I gain is set at 5, which is right in the middle for both areas. Down here at the bottom, where my finger is, you have what looks like a rotor blade. Okay, that is your auto rotation bailout time. All right, right now I have it set at 25 seconds. So if I hit throttle hold, and as soon as I go past 25 seconds, the ESC is going to automatically default back to the soft start. Okay, so if you want the instant power on when you turn back on your when you turn off throttle hold, I would have to do it within 25 seconds. After that, it's going to go back to the slower spool up. So you really have to pay attention to this. So if you're going to be doing a lot of auto rotation practicing from higher altitudes where it takes the helicopter longer to land, you're probably going to want to set it to 35 seconds, which is option 3. But just to show you how I set it, I'm going to hit the what looks like the helicopter rotors. I'm going to hit 1, 2, and then 3. It takes it, and now I'm set at 25 seconds. So, and then once you're done programming, you just take your switch on the receiver, or on the IR receiver, put it in the PM mode. The series of tones tells you that it's now activated again, and it's good to go. And that's pretty much all there is to programming the ESC. There's not a whole lot to programming it. Now it's time to unplug the helicopter and go ahead and put the blades back on. This Loctite that I used, or the thread locker that I used, requires a 24-hour cure time for it to hit maximum strength. So at this point, this bad guy is just going to be sitting here, and I still have to put the battery tray back on, which is, I'm not going to bore you with those details. And pretty much there she is. New motor, new servos, new ESC. Next on the market for me is going to be, let me get this out of the way, it's going to be to replace the GA250. So we'll see how that goes. Anyhow, hopefully y'all found this informative.